So joining us today from St. Johns County Utilities in Florida is Rick Nelson. He's the SCADA Department Manager, and Randy Howell, the Senior SCADA Tech. Gentlemen, welcome today. Thanks for joining us. Can you tell us a little bit about St. Johns County, about what you do and who you serve?
The St. Johns County SCADA Department maintains the instrumentation control systems for all the water, wastewater, and lift stations and booster station facilities for the county, which stretches over 800 square miles. Additionally, we aid operational staff in maintaining and monitoring the systems, diagnosing equipment and instrumentation failures, and the maintenance of the communications networks, as well as aiding engineering staff with managing growth and development within the utility. Well, I'm the department manager. I started this department by myself and was able to bring individuals in, and now we're a department of 5 people.
So I come from an integrator background, but as an integrator, I came from the submittal, the design, the panel build, the programming, the startup testing and debugging and documentation. So that's something I'd try to maintain here. We didn't have a lot of that when I first came aboard, so helping bring that under the same blanket has, I think, been a big help for the county. We're implementing standards. We've recently been working on alarm management and conforming to ISA 18.2. We're also kind of gearing towards the high performance and situational awareness schemes with our HMI screens. As a technician, I kind of do the development, the debugging, and a little bit of the advanced troubleshooting. So the county's had VTScada since 2008. They had a contractor that kind of ran an OEM system at that time. And then in 2012, the county began to realize they were going to continue growing and they wanted to kind of bring that all in-house. Ever since then, we've maintained a handful of integrators. They're experienced in Motorola and in VTScada, and then we utilize them as additional resources to what we have for larger projects and technical support when we need it.
Right. How many sites does this include?
As far as lift stations and plants and boosters, approximately 300.
Can you tell us about the hardware?
We're a Motorola shop for the most part. We have a Motorola MOSCAD is what we had a majority of when I started here in 2012, and Motorola ACE PLCs is what we're slowly migrating to as we upgrade our legacy sites.
Now, you're using VTScada software. That brings us to the main event today, which is that you've upgraded the system to be able to bring in data from your 4RF digital radio network. Can you tell us about some of the goals you had going into that process?
Yes. Well, my background is radio. I'm an old Motorola field tech rep, and I've always realized that radio is one of the most important parts of a SCADA system. If you don't have good, reliable radio communications between your remote sites and your servers, the system is not going to be very helpful to you. There's been quite a history of us coming in the morning or getting calls in the middle of the night. Hey, I've got a communications failure at a lift station or a water plant. Lo and behold, when we go and investigate it, we find out that there's actually been problems that have been happening a long time that we really wish we had caught sooner. I've always known that the digital radios, and most of the digital radios that are produced today, have the ability to send alarms out and use various software. But it was really my goal to be able to bring this all into one package. We love to use VTS; it's our favorite software, and I wanted to find a way to actually build a page that monitored our 4RF radio alarms. And we got with Star Controls and asked them if this is something they were interested in helping us develop, and they absolutely were. And we got them a task order, and within about a month, we had a pretty good working page. Almost immediately, it started showing us through trends some site failures that we had that we didn't know we were having, by showing us that we had some high reflected power or some dipping signal to noise ratios on the radios that we just weren't aware of. We were able to get out to these sites and find that sure enough we had water in the coax, an antenna failure allowing water in, and even though the site was still communicating relatively reliably, it was on the path to a catastrophic failure in the very near future. And we were able to prevent that failure by being proactive. And that's really what this page has allowed us to do. It just works really well.
So, Randy, would you take a second and actually show us this new screen so we could see how it works?
Yeah. So this is the overview, so to speak, for all of the sites that are under this master. We currently have one of the masters online with 60 remote sites that talk to that radio. In the screen, it's laid out. You've got the site name on that far left column, and then each column going to the right. In terms of signal strength and data, you've got two perspectives. You got from the master to the remote, and then from the remote to the master. So from the master to the remote, it's the first two columns. The third and fourth are from the remote to the master, and then all data that comes from the remote site itself. So the internal temperature of the remote radio, the transmit and receive duty cycle of that radio. The RX alarm is kind of an internal alarm to the radio. It's just like a general status. So if there's an alarm within the radio, that'll change to an alarm bit, send an alarm that we can monitor. Gives us our power settings for the radios. And then on the far right here, it's also got the reflected power, which is one of the key indicators for an ongoing issue with the radio.
Measured in percent. We have the one column that shows the transmit forward power. Some radios that are closer to the master than others, we don't necessarily need to use the full power. We can turn the power down on the radio. The transmit power, reverse power, that's how much reflective power is coming from the antenna, and that tells us a whole lot about how that antenna is radiating the signal. When you start pushing 10% reflected power, which you can see a couple in the screenshot that are actually exceeding just by a little bit the 10% threshold. Those are sites that are all working really well right at the moment, but we intend to get out to those sites and run a return loss on that antenna. And in some cases, it's as simple as some tree branches that have grown in front of the antenna, really close. Other instances are just some simple tuning on the antenna. We have a couple of versions of antennas that we can actually tune a little more to the center frequency of the particular radio we're at. But in most cases, what we've been finding is that some of the other antenna manufacturers we've been going through are a little more susceptible to water intrusion than others. And we've finally got to an antenna manufacturer where we don't really have that issue anymore. Every one of these have been some antennas that have invariably had a little water intrusion in the coax.
This looks great. You mentioned trending before. Can you show us an example of how you use trends with these values?
You bring up your HDV, your data. You can set it for whatever time frame you want. If you've got water in your coax, or if there's an issue with the antenna, you can see that it would slowly degrade over time. Right now, a lot of the stuff's kind of just holding to where it is, which is what you would want to see. But it gives us the ability to look at that signal over time, to really gauge what's going on with those antennas. I think one of the neat things is being able to look at the temperature and see the temperature go up and down throughout the day and
now,
overnight.
this is an internal temperature of the radio. It's not the actual temperature inside the cabinet, but it does give us an indication of whether or not there's some sort of a problem in the cabinet or in the radio.
So once you create that trend, I assume you're able to export that data to a spreadsheet to work with later?
Correct. We just use the onboard tools that VTScada has available and the historical data viewer that does that.
That's great. So you can just click on as many different values as you want and just add them to the trend.
Correct.
Absolutely.
Excellent.
And the trends are that's something the radios that we use, the 4F radios, have a rudimentary way of trending, but it's nowhere near as detailed as this is. These screens update every 15 minutes, is it?
Yeah, we have the polling rate set to every 15 minutes, so it's not kind of overboarding the rest of our system.
But the radios only let us look at the previous 24 hours. There's another rudimentary trend that lets us go a little further back, but it's nowhere near as detailed as we're able to do this with the VTScada screens. Right. And it's a really good tool to help us. Like if we have a heavy rainy day, we can see and we start seeing the trend go downwards for some of these. The reflected power or the signal to noise ratio, that's another key indicator of some sort of an issue. The signal to noise ratio can also be an indicator of other RF interference, be it atmospheric or somebody else putting a signal in on your system, so that helps troubleshoot.
There are a couple of neat features on the screen. You can organize the columns alphabetically, or the numerical ones, you can go from least to greatest to least. So more so on like the reflected power, you'd be able to see which sites are performing worse than others. So you can identify which ones are above whatever threshold you want to set. And then another item was when your values go within certain ranges, we asked Start Controls to develop it to where it would change colors based off the alarm values or the thresholds that we set. so we can kind of identify it and kind of give that situational awareness where you first look at it, you see the ones that really stand out. And we had different ranges, different colors.
We set our bottom threshold for the signal to noise ratio to change colors at below 23 dB. Really, we don't like to see our signal to noise ratios go below 26. And anybody who's a radio guy like me will understand, especially digital radios, that when you start getting below 26, that's when the error rate starts increasing.
Right.
We set our threshold at 23, and those are the sites that are the real problems.
So it allows you to horn in very quickly on where emerging problems are.
This tool has really been awesome for us.
That's great and looks great. So how long did it take Star Controls to create this for you?
We gave them the task order, and it was about a month in development and before we implemented it. Truly, the changes we made, a lot of it was cosmetic. They were very, very awesome in their support, and we got everything cleared up, and you see the final product right there.
Like we had said before, we have about 300 remote sites. These are all of our lift stations. There's upwards of around 240, but we use our system for additionally all the local water and wastewater facilities that we have. They're actually running standalone applications on those sites, and then we utilize the master subordinate feature within the application. So we're running all these concurrent applications under one machine that's able to monitor all of them through the same application. So any of those standalone applications you can access through the one application. So we have our Northeast water plant. You've got the overview for that, or you could jump to one of the wastewater plants and you've got the overview for that. And all the sub pages that are children to those applications as well. You can access all of that through the same root application.
That's great. So Master Subordinate Applications is a new feature that was released in VTScada version 12. So it's nice to see that out in the real world. So what advantage does that offer you, being able to have a master application that can read from these subordinate applications, as opposed to having them all be one big application?
In terms of simplicity, for me, it's less work. In terms for the county, it's only having to contract to do the work one time, rather than having a local application and then a enterprise application, so to speak, to where they have to develop it in two separate areas in order to see it in multiple areas. It's all done in one spot and you're able to see it anywhere.
It actually helps us save some money, so we don't have to pay a vendor to do the same thing twice. Once out at our remote HMI, and then they have to drive all the way out to our office in part of the county. It's a long drive to get here and to do the same thing when they can just make the upgrade, save it, and it automatically is downloaded through the servers.
Obviously, you're on a roll now. What's next?
For me, I'd like to conform all of the remote sites and the standalone applications to more of the high performance screen layout. In terms of the 4RF upgrade, we have 7 total master towers. The 4RF data we're bringing in now is only one master with the 60 sites on it. We currently have just over 200 digital radios out in the field. We want to bring all of those into the system as well, so we can monitor and maintain and perform the preventative maintenance that we need to keep that system integrity in place, as well as upgrading our legacy equipment.
Well, thank you, gentlemen. We really appreciate having you here. Joining us today was Rick Nelson, the SCADA Department Manager, and Randy Howell, Senior SCADA Technician at the St. Johns County Utilities in Florida. Thanks so much for joining us.
You're very welcome, Chris. Have a good day, sir.
You too.